Everyone, how you guys doing today? So welcome back to Don't Fail Asking Mikhail. Today we're gonna discuss the logarithm rules or the property of logarithm, right? So the other video yesterday we went over how you convert between log and exponential forms and vice versa, exponential to log. Today we're gonna talk about some properties of log and how you use log in real numbers. So the first property that we need to be aware of, number one, is called the product rule. The product rule is very much when you have log m times n equal to log m plus log n. So what you want to say here is if you have multiplication, to split it, you have to change to addition. It's like log xy equal log x plus log y. Or what if I have log 3x? That's multiplication. 3 times x. That will equal to log 3 plus log x. Log the first plus log the second. That is rule number one. The second rule, let's change the color, is the quotient rule. To log m over n. Remember, folks, over here I have multiplication, and in multiplication will change to addition. Now this is division, so I'm going to change it to, or actually we'll call it expanding, to subtraction. So that will be log m minus log n. And it's very important that you know it's log the top minus log the bottom. Log the top minus log the bottom. So for instance, if I have log 3 over x, that equals log the top minus log the bottom, x. How about log 2/3? Wait, that's Mikhail, there is no variable, like no x, no y. Both are numbers. The 2 and 3 are numbers. It's fine. It works for everything. That equal, remember, a number is a fraction. So that is log 2, which is the top, minus log the bottom, which is 3. So now what I did here, I changed division into subtraction, m over n in subtraction. M times will be plus, m over will be minus. All right, what else? Let's do another rule. Rule number 4, which is the most important rule, that's what I always say, that is log m to the power n. Every time you have an exponent and a log, what happens with the exponent is jumps in front of the log, and that will be n times log m. Example, log x squared. So as you see, there is an exponent here, and we have log. Every time you have an exponent, what you do, you take that exponent, you put in the front, and that will be 2 log x. All right, how about log 3 squared? That will be 2 log 3. And to prove this one, to prove it, remember log x squared is the same as log x times x, because every time you have a square, the square is multiplied by itself. So if I go back to the first rule, that is log x plus the second, which is log x, which is equal to 2 log x. So these are the most 3 rules, and we're gonna practice in a second. Now, you have 2 other rules. The first one, when the base equal to the argument, like log BB, that always equal to 1. And if you act, that makes sense actually, because if you try to convert this one as exponential form, b to the power 1, if you follow the arrow, equals to b. So log 3 base 3 equals to 1. That's why log 10 by itself equals to 1. Can someone know why? Excellent. Because the base is already what? Invisible 10. All right. Another rule. The last rule. log 1 equals to 0. Do the matter what the base is. And let's take this one as exponential form. This to this, does that make sense? Anything to the power 0 equals to 1. So that's why log 1 always equals to 0. All right. Now, let me show you something. What if I have log 3 that equals to what? Can I say that's log 3 times 1, which is log 3 plus log 1. And now log 3 is log 3, and log 1 equals to 0. So as if I'm adding 0, which is equal to log 3. That proves what I'm saying. All right, let's have a couple of examples. We can apply the rules. Let's have log 2, if we use the calculator, let's have log 2 to equal 0.3010. Log 3 is equal 0.4771. And log 5 equals to 0.6989. Now, say I have these logs here. All right, say I have these logs here. Using the property of logs, I want to know what is log 6. Mikhail, log 6 is not here. Log 6, I have log 2, log 3. But using the property of logs, I can know log 6 by using 2 and 3, and that will equals, using the property of log, that is log, I can replace 6 to be equal to 2 times 3. And that will equal log 2 plus log 3. Do I have the value of log 2? Yeah. So I'm going to take log 2, which is this. I put it here, which is equal to 0.3010 plus log 3, 0.4771. And that will give me 0.7781 if I add them. And if you try to check in the calculator what log 6 is, it will equal to 0.778. So the key for this lesson is how you break these numbers into little small numbers using the property of logs. So what is log 9? That is log either 3 times 3 or 3 squared. Now using rule number 3, jumps in the front, there is 2 log 3, and now you use the value of this log 3 2 times whatever log 3 is over there. Another example, log 12. Now, remember you always have 3 numbers only, 2, 3, and 5, because you only know the value of these number 2, 3, and 5. So how can you use 2, 3? You didn't have to use them all. You can use just 2 numbers, but you're all allowed to use these 3 numbers to make the 12. Excellent. Someone is saying that is log 4 times 3. And what do you know about log 4? That is log 2 squared times 3. And that will equal, using the first rule, log 2 squared plus log 3. And that will make it, using the rule number 3, 2 log 2 plus log 3. Then you substitute. Now, another example. I have 45. 45. Think, how can I get 45 from just 2, 3, and 5? Well, 45 could be broken down into 5 and 9. Oh, what do you know about 9? Excellent. That's a 3 square. So that is log 5 times 9, or 3 square, or vice versa, 3 square times 5. All right, that will equal to log 5 plus log 3 square, and because of this, it jumps in the front, so that is log 5 plus 2 log 3. Then you substitute with the value of each. All right, log 12.5. All right, let me tell you something, everyone. Every time you have a decimal, that means it's a fraction. All right? So think of a number you divided by another number, give you a fraction. So over here, every time you have 0.5, you very much divide by 2. Like in this example, that is the same as log 25 over 2. So you do vice versa. You multiply by 2 to know the top, and you put 2 on the bottom. So 12.5 is 25 divided by 2, and that would be log 5 squared over 2, which is 2 log 5 top minus bottom, log 2. Remember, this one is like log the top, which is 5 squared, minus log the bottom, which is 2. And what I said here is 2 log 5 minus log 2. 2 log 5 minus log 2. And now, you know the value, just put them in. How about this example over here? 0.33. When you have 0.3 on the bottom, at the decimal, that means you have 3 on the bottom. All right, so that is something over 3. So what do you think? What's something over 3 will give you 0.3? Someone is saying something good. I like it over there. Someone say, Mikhail, can you convert this one as mixed number 3 over 10, and you convert it? Yes, you can do that. All right, you can do that. So, but you do not know what 33 over 10. You don't know what 33 is. So let's think of another way. Log 3.3. Two numbers you multiply give you 3. And the decimal here is so excellent. Someone here is saying 10. Yes. Oh, I'm sorry. I made that mistake. 10 over 3. What is 10 divided by 3? Or you multiply. Another way, which is the best way, you know it's over 3. Multiply whatever number you have here by 3. Give you 10. Or, like what I did on the top here, stay with me, like what I did on the top here, I multiply 2.5 by 2, I got 25. Multiply 3.3 by 3, you get 10. So that equals 2 log the top minus log the bottom, which is 3. Now we know log 10 from the rule equal to 1 minus log 3, and if I substitute. Now, how about 0.2, 7.2? Anytime you have 0.2 on the bottom, that means the bottom is, as a decimal, that means the bottom is a fraction. Every time you have 0.2 at the decimal, mean the bottom is 5. Sorry, I took it too much. Anytime you have it 0.2 at the decimal, that means the bottom is 5, and you need to multiply that number by 5. So if I multiply 7.2 times 5, I'll get 36. So that means it's a 36 divided by 5. And what is 36? All right, log 36, you can say it's a 6 square divided by 5. Someone gonna tell me, Mikhail, I don't know what 6 square is. Yes, but you know that is log 6 square is 3 times 2 divided by 5, but 6 is the only one has the exponent, you put parentheses. So that equals log the top, and the top is 3 times 2 square minus log the bottom 5. Now use rule number one, I'm sorry, which is multiplication, and 3. And rule number 3, which is exponent, and that will be log 3 plus log 2. And remember, this both here, you gotta put the 2 here for rule number 3 to minus log 5. And now that's 2 times the values for log 3 and log 5, log 2 minus log 5.